Imagine transforming a single, beautiful painting into a living, breathing scene. What was once a static image is now a dynamic video full of life and motion. This isn't magic, it's the power of image to video AI. I created this animation using a tool called Hailuo, hopefully I'm pronouncing that right, AI. I stumbled upon it recently, and I have to say, I was really blown away by how far image to video technology has come in such a short time. My first test, turning a picture of a dog into a video. My prompt was simple: make this dog happy to see me. And the results were pretty good, although the extra movement in the background isn't ideal. Then I tried it with my own pets. This one's honestly my favorite. Not only does it animate my two cats, but the two cats became three as the AI decided to add a third phantom cat into the mix. It shows that the AI can still make some stuff up. The real test was with AI-generated people. Could I get them to talk naturally? And the results show a technology that's rapidly evolving, but not without quirks. That's not what this video is about. Today's video is what's actually going on behind the scenes. How does this AI turn still images into videos? That's what we're going to explore. I'll break down the core concepts in a way that's easy to understand, but if you're not a tech expert, be warned, there will be some technical parts, but I'll try to keep it as lighthearted as possible. At its heart, image to video AI boils down to four key processes: image analysis, motion prediction, frame generation, and refinement and enhancement. Image analysis first, the AI analyzes the input image. It's like giving the AI a pair of superpowered eyes to identify every object, understand their boundaries, and figure out how each relate to one another. This detailed understanding of the scene is crucial for creating realistic motion later on. Next is motion prediction. Here the AI uses its understanding of physics, common motion patterns, and object interactions to predict how elements in the image would naturally move. A recent Google study showcased an AI model doing just that, analyzing elements in a photo and generating a video predicting their natural movements, like a swaying tree or a flickering candle. With motion plan in place, the AI starts generating new frames to bring the image to life. This involves techniques like interpolation, creating frames in between existing ones, and extrapolation, extending the motion beyond the original image. Refinement and enhancement is the final step, where the AI enhances and refines the generated video. It adds transitions, it smooths out effects, and realistic detail like shadows and reflections, and even incorporates special effects to make the animation as polished and believable as possible. Now, let's dive a bit deeper into the underlying techniques that power this process. Generative Adversarial Networks, or GANs, are like two artists working together in a creative duel. One, the generator, creates new video frames. The other, the discriminator, acts as a critic, judging how realistic those frames are. This constant back and forth pushes the generator to create constantly convincing video frames. Both the generator and the discriminator are neural networks. Convolutional neural networks, or CNNs, you can think of like the AI's eyes. They excel at analyzing visual data, helping the AI understand the content and structure of the input image. They identify objects, recognize patterns, and extract features that are crucial for motion prediction. Recurrent neural networks, or RNNs, are like the AI's memory. They're great at processing sequential data like the frames in a video. RNNs help the AI understand how objects move over time and generate smooth, coherent motion. Optical flow estimation helps the AI predict objects' movement between frames, creating a sense of continuity. It's like tracking the path of a ball thrown in the air. The AI anticipates where the ball will be in the next frame. Attention mechanisms allow the AI to focus on the most important parts of the image during its generation. It's like an artist paying extra attention to the main subject of a painting, ensuring key details are preserved and enhanced. Diffusion transformers are a newer type of neural network that refines video frames step by step adding details and motion in a process similar to an artist adding layers of paint to a canvas. Now let's talk about one of the most advanced techniques in this field, video latent diffusion models, or video LDMs. What are video LDMs? Well, they are cutting-edge AI models designed to generate videos. They learn from vast amounts of existing video data, similar to how you learn by observing the world around you. What makes them special is that they build upon the success of image-based LDMs, but with a crucial addition, the ability to understand and process time. This temporal dimension allows them to capture motion, changes in the flow of events over time, which is essential for creating realistic videos. One of the key innovations behind video LDMs is their ability to work in a compressed, lower dimensional space called the latent space. Think of this like instead of dealing with the massive amount of data in a full resolution video, they work with a simplified, more compact representation. It would be like summarizing a long book into a few sentences or a couple paragraphs. This makes the entire process much more efficient. Essentially, video LDMs extend the capabilities of image-based LDMs. While image LDMs are great at generating single images, video LDMs can handle sequences of images, putting them together to form coherent and realistic videos. It's like the difference between creating a single painting and producing an entire animated film. Training a video LDM is a multi-stage process, like learning a complex skill through different levels of practice. First, many video LDMs start with a pre-trained text-to-image model. This gives them a basic understanding of visual features, patterns, and how text descriptions relate to images. It's like laying the foundation of a house before building the walls. Next, they are trained on a massive data set of videos. This is where they learn about movement transitions and how events unfold over time. It is like a film student watching countless movies to understand storytelling and cinematography. Finally, they undergo fine-tuning on a smaller, high-quality data set. This step refines their ability to generate high-fidelity videos with sharp details, smooth motion, and overall visual appeal. You can think of this like a musician practicing scales and perfecting their exercises to get the perfect technique. Importantly, during these training stages, temporal layers are incorporated into the model's architecture. These layers are essential for capturing the relationship between frames and ensuring the generated video flows naturally, like the frames in a flipbook, creating the illusion of motion. As we discussed, video LDMs operate in a compressed, latent space to make computations more efficient. These temporal layers are the secret sauce for capturing the dynamic of videos. They use techniques like temporal attention, which allows the model to focus on the most relevant parts of a previous frame when generating the next. Or they might use 3D convolutions, which process information across both space, like in an image, and time across frames. Many video LDMs employ what's called a UNet architecture. This type of neural network is particularly good at understanding both the overall context of a video and its fine details. It's like having a wide-angle view and zoomed-in view at the same time. Some video LDMs like Stable Diffusion and Text-to-Video Zero take a shortcut by leveraging pre-trained text-to-image models. This is a clever approach because these models have already learned a lot from massive image datasets. Models like Stable Video Diffusion add temporal mixing layers to these pre-trained models. These layers help the model learn the relationship between frames and generate coherent video sequences. AnimateDiff takes a different approach by inserting a motion module into a pre-trained diffusion model. This module allows the model to animate images and generate videos by learning motion patterns from video data. And then there are models like Text-to-Video-Zero, which are quite remarkable. They can generate videos directly from text prompts without any specific video training data. They achieve this by animating the text prompts with different motion dynamics, such as walking, running, or flying. It's like having an AI that can instantly visualize your words into a short film. While video LDMs are incredibly powerful, they do have limitations. Computational costs, for one. Generating high-res videos is computationally expensive, requiring insanely powerful hardware. They have a lot of sensitivity to noise. The initial noise distribution can affect the output, making precise control super challenging. Then there's control challenges. Fine-tuning and controlling the output to achieve specific results is still an area of active research. Limited length. Current models are typically limited in the length of videos they can generate. All the ones you saw here in this video are just a few seconds long. And then realism. Capturing the full nuances of human emotions and behaviors remains a challenge. And the consistency in longer videos can be very difficult because you get inconsistencies in motion or inconsistencies in appearance creeping in. I don't know if you noticed in that video with my cat, my cat's face and colors changed a lot. I tried to generate a specific video with Hailuo AI, and the results were, well, not quite what I expected. It highlights that even the best models have limitations in interpreting and executing complex instructions. Even with a tool as advanced as Hailuo, I couldn't generate any of the technical diagrams in this video. I tried several times, but the model clearly struggled with creating and animating these types of videos. This is because current image-to-video AI is still primarily trained on real-world footage. It's exceptional at mimicking natural movements and physical interactions, but it hasn't yet grasped the intricacies of abstract representations, like diagrams or complex data visualizations. Its understanding is rooted in the visual patterns it has observed in real-world data, not in the symbolic or conceptual meaning behind abstract shapes and figures. Image-to-video AI is rapidly evolving. We're witnessing an incredible amount of advancements, but we're also seeing the limitations of the current technology. The journey from static images to dynamic, realistic videos is very complex and full of challenges, but with each iteration and with each new model and technique, we're getting closer to a future where AI can truly understand and generate any visual content we can imagine. It's super exciting to be watching this space, and I can't wait to see what the next breakthrough actually will be in this space. Guys, thank you so much for watching this. If you made it this far, I appreciate you, and it would mean the world to me if you like and subscribe. I spent a lot of time researching and putting together this video, and I left links below so you can check out Hailuo yourself. If you sign up for a new account, you get 1,000 credits for generating images. I will tell you some of the wait times for the processing can be very long. I'm not sponsored. It's just a service that I ran into and I wanted to explore a little bit more. Anyway, until next time, take care and peace out.